All seems calm at the University of Ottawa's engineering building, but under our feet, explosions are a regular part of the routine.
My research interests include performance of buildings and bridges under extreme loads, and these extreme loads include earthquakes, bomb blasts, and also tsunami.
In his blast research lab, the only facility of its kind in Canada, Dr. Murat Saatcioglu uses a machine called a shock tube to simulate explosions. His team designs and develops construction materials and techniques to strengthen structures, then submits them to controlled blasts to see how they fare.
We are able to test and do research to save structures against blast, retrofit them, strengthen them, harden them under blast-induced shock waves.
One of his retrofitting tactics is to wrap columns with fiber-reinforced polymer, or FRP, to prevent the concrete from expanding or cracking in a bomb blast. He also tests braces and coating materials.
We spray polyurea, which is the same material that is used to protect truck bed liners against corrosion. So it sticks on the material, it becomes like chewing gum. The brittle masonry can deform excessively and bounce back, and you control the debris, which would otherwise fly in and kill people, and you also protect the structure.
Saatcioglu has also developed new and innovative seismic retrofit technology to protect reinforced concrete structures against earthquakes. His structures lab is equipped to simulate earthquakes in slow motion to gauge the level of protection this new technology provides.
These buildings contain a lot of old infrastructure. Buildings built prior to 1970s did not utilize the current seismic design methodologies that we know, and hence they are likely to be seismically deficient. Frames are not ductile enough to be able to bend and bounce back, but if you push it a little bit, they collapse. This is brittle behavior as opposed to ductile behavior, which then would move back and forth, absorb seismic-induced energy, and sustain their strength.
Saatcioglu tests building components such as beams, columns, walls, windows, and doors to see how they would react in the event of a natural disaster or a bomb blast. He applies different materials and methodologies to building components across Canada to prevent a collapse that would result in devastating human and economic losses. These techniques eventually become part of Canadian building codes and standards.